Hey, Professor, coming back at you with some more math problems. We're back at home now, and I got my own personal whiteboard, so I can do everything at home, which is real nice. Um, so today we're doing problem 8.1 for point 5, and this is looking at sequences. So we're giving the function uh, ln of x over x, and we're first for a we're supposed to find the first 10 values. I started at 0, so my 10th value is 9. Um, but if you start at 1 and then go to 10, then it's probably give you a prettier number. But so x is equal 0, we get it's not divisible. We get x is 1, we get 2. X is 2, we get 0.3466. X is 3, we get 0.662. X is 4, we get 0.3466 again. X is 5, we get 0.219. When x is 6, we get 0.2986. When x is 7, we get 0.2779. When x is 9, 8, we get 0.2599. And then when x is 9, we get 0.244. And in part B, there you go. We're told to graph these first 10 values. So it's basically just graphing the log function, log x over x, and then stopping it at 9. And we see that, of course, it never touches 0, so that's why we get that weird finite number. And then at 1 we get 0, and then it's just slowly decreasing as we go. And we're told to also see if we could try to find if it or see if it's going to converge or diverge just from looking at these two. And at first glance, you look at it and you're like, oh, it might converge because you see it's going towards 0 as x gets bigger. And then in part C, up here, we're told to actually see if it converges or diverges using a test. So if you want, you can do the divergence test, but if you do the divergence test with ln of x over x, you see that it approaches 0, so it's not really going to tell you anything. So that means you have to do another test. So I kind of just transformed it into a integral in order to solve it, because series are basically like integrals in a way. So if you solve the integral, then you know the series, and then therefore you know the sequence as well from the series. So that's what I did. So we have the sum to infinity starting at x equals 1 of ln of x over x. So then we take the integral from 1 to infinity of ln x over x d of x. So then we turn that into a limit. So limit as b approaches infinity of 1 to b of ln x of x over d of x. And then down here, we can easily split it up into the integral from 1 to b of ln of x times 1 over x d of x. And we can take a u sub in order to get u as ln of x. That means du is 1 over x d of x. So then, once we change the bounds and rearrange it, we get the integral of ln of 1 to ln of 0 u du. And then we can, of course, simplify and solve that down here. So we get the limit as b approaches infinity of u squared over 2. And then evaluate that from b to ln of 0. And then ln of 0 is, nothing. So you can't really do that. So it's basically just u2 or ln of x over x squared over 2, and then we see that it kind of goes to infinity. So the the integral diverges, which means the series diverges, which also means that the sequence diverges. So then we know the answer to part C. Element of x over x diverges. So yeah, a reflection for this video. I think I talked too fast. I hope I didn't, but I think I did. And I think I could have spaced everything on the board a little bit nicer. It looks a little bit messy. But other than that, I think it was alright. And I'll be coming at you again here soon with the next one once I write everything on the board. Alright, see you in a couple minutes. Bye.